from last night, just to make sure we're on thing. And then we're going to finish up the notes today, and that'll be the last notes that we get to. Tomorrow we'll do review, Thursday chapter test. Don't forget the spiral review is due on Thursday, if you haven't got to that yet. Okay? So eventually I'll come around for notes. I didn't last period, so I guess I'll wait till tomorrow to come around while you guys are doing your review. But I do want to do one from yesterday, because really that's the big deal, is what if you can do yesterday's. So you want a graphing calculator for sure if you don't have one. But I think we did we do 37 yesterday?
37.
Is that what we didn't, did we get to any of them yesterday? From 29 to 39? Okay, is there one that we can do then? Someone want to do one? Pick one and we'll do it. It doesn't matter to me.
35.
35. All right, here we go. We got 35. So I will say, if you can do any of these problems, you should feel pretty good about the chapter test, because basically you're doing all of these steps. Like the whole chapter is leading up to basically these problems. And the directions say, find all of the zeros, bless you, of each function and use them to sketch a rough graph. How many zeros are we looking for? 3. What happens if we count signs right now? What would that tell us? Yeah, how many sign changes are there here? So what's that tell us? Yeah, that means there's one positive real zero. Okay, so now what? So then what you're really doing is evaluating at negative x, and so what does that do for, like, how we write this out? That exponent sign changes. Okay, so then it's negative x cubed plus 7x squared minus 4x minus 12. Okay, is that okay with everyone? And so then what does that tell us? 2 or 0 negatives. Negative real zeros.
Wait, so why did 7x not change?
Because it's x squared, 7x squared, so it's a even power. So when you square a negative, it stays positive, so it's not going to be able to change the sign. All right, I think it's a good idea to do this chart. So we're talking about positives, negatives, and imaginary. So what are all our options here? One positive for sure. Could be 2 negatives, and then you would have how many? 0, because we have to add up to 3. Or we definitely have 1 positive, 0 negative, which makes 2 imaginary. Is that okay? All right, so if we didn't do the example, maybe I didn't quite get to all of this with you guys, but that example was just choosing randomly numbers. They just started like at -3 or -4 or whatever, and they just kept going. And then yesterday I mentioned like that doesn't really make sense to do. And since we're not doing all of the theorems, then I think we should do a hybrid of doing it by hand and by the calculator. So I want everyone to go put in the original into the y equals and graph it, and we will for sure have 1 positive. And when you find that positive, let me know. You can go to the graph and should be able to see where it crosses. Is that one, can you put that one like, don't plug it back in because that one hasn't been working for some reason. Yeah, put that, yeah. Because it didn't even turn on. Is that, yeah, okay. All right, so graph it. Go look, and it should be something that we can find. Did anyone find what it is? I didn't hear something.
It's like a sideways S. The graph is.
So it's like a sideways S. Okay. So can you tell like any of the zeros? He says yes. So what do you got? Oh, so you found them all. Is that what, you can see all three of them? So what were they again?
-6, -2, and 1.
Okay, so I'm going to pretend that we couldn't find all of them. Because I'm fine if that's how you guys do it, okay? But they're not all, sometimes we're going to have imaginary. So here's what you would do, pretending we only found one. Like, which one do you want to pretend we found? -6. Okay, so let's say that's the only one that we found. So we want to find 3 of them. Okay, and so then what we would do is take -6, put it in the box, take the original coefficients. Now, if this truly is a 0 for this polynomial, what's going to happen here? And the remainder, right? Okay, so then what happens? Let's do it.
And then -6.
And so for sure, that's one of them, right? And then what you would do, you might have to do it again, but this one only started with an x cubed. So now we're in an x squared. So we don't have to do it with another one. You could, if you had another one. Again, if you already can read them off, then that's fine with me, as long as you can answer all the questions that they're asking. But what we have now is x squared plus x minus 2. We could set that equal to 0. This actually factors. So factors is -2, that add to give you +1. Say it again. 2 and -1. Set both of these equal to 0. And sure enough, he was right. Those are what they are. So, if you can't factor, then you could do the quadratic formula or whatever you need to there. Is that okay? All right, now I want to point out, because what we're going to talk about here in a second, right? If your solution is -2, the factor is x plus 2. Is that okay? The solution is +1, the factor is x minus 1. Is that okay? All right, so I'm pointing that out. All right, so is that okay? Is everyone feeling okay about that? All right. So then we're on example 4 then. And this is page 287, 288, 287. And they say use a graph to write a polynomial function. There's a whole bunch of them, but we're just going to write the most simplest one. The graph crosses the x-axis how many times? The x-axis? 3 times. Oops. Get that white there. 3 times. Okay, so then the function is at least a degree of at least 3. And then it crosses the x-axis at -4, -2, and 1. Does that look right? Okay, so then we're going backwards then. So that means our factors are x plus 4, x plus 2. All right, does everyone see how that happens? Okay. And so then they want the polynomial. So then we set them up. So we're just like working backwards from like the answers to a factored form, and now we're going to distribute everything. So don't get carried away. Only do 2 parentheses at once. So they're doing the +4 and the +2. So when that FOILs, what do you get?
X squared plus 2x plus 4x plus 8.
Okay, and then that would simplify to x squared plus 6x plus 8. Is that okay? All right, so then we have to distribute again. So what's that going to look like? X cubed
Minus x squared plus 6x cubed,
Squared.
or squared, yeah. Minus 6x, plus 8x, and then minus 8.
Okay, and so then we simplify that down. X cubed plus 5x squared plus 2x minus 8. And so then that would be our function. Okay, now this is super easy to check, because if you type in that function, you better get something that looks very, very similar to that picture, specifically going through those zeros. Okay? Is that okay? All right, let's do a check real quick. You tell me. Or you do it. I'll slowly do it. How about that? Is that okay?
I got B.
You didn't foil all the way then.
Mm.
You did, B would just be if you foiled x plus 8 and x minus 4. So that part's right, but then you still got to distribute that with x plus 2. Okay, so you just didn't finish it.
Mm.
Anybody else? Okay, one more.
Yeah, how'd you get 10x?
So, right in here, right, I've been x squared plus 2x, and then plus 8x, right? So then, yeah, okay, so there's a 2x, there's the 8x. Okay. All right, is that okay? One more. Profit margin. All right, use zeros to graph a polynomial function. A book publisher wants to release a special hardcover version of several Charles Dickens books. They know that if they charge $5 or $40, their profit will be zero. Graph a polynomial function that could represent the company's profit in thousands of dollars given the price they charge for a book. All right, so what are we going to do? What could we do? What's Y stand for? Profit. What's X stand for? What's X stand for first? What do you?
Profit.
The Y is the profit, so X is
How much they charge each other.
how much they charge for a book. So what's happening when they charge $5 for a book?
They're not making any profit.
Yeah, making zero profit. So that would be one of our roots, right? Because that's where it's crossing the x-axis. Is that okay?
So it's 5 and 40 or 0?
So then 5 and 40 are zeros because they're telling us that what they have is zero profit when they charge that amount. Okay. All right. So if those are our zeros, what do we do? Yeah. So you're always switching the sign, right? So then we have this function. Okay. So what should we do with that? All right, so then this profit function, I'll do P of X for profit. So X squared minus 40X minus 5X plus 200. So we're saying this profit function looks like this. All right, so put that in your graphing calculator.
Just do formula for that, right?
Well, so we could solve and we could find that they are 5 and 40 again. But we want to graph this thing. They're asking us to graph it. So put it in your graphing calculator. And then, right, they give us this little graph here. So I want you to pull off, I would just go to the table. And I know what 5 is, and I know what 40 is. I know 0 is 200. And so then that would make 45 200. So what else, like, give me, like, what is 10?
Negative 150.
And then what is 15? 250? Is that what you said? Negative 250, yeah. 20 would be
300.
negative 300. 25. All right, so we must have just passed the vertex. Vertex would be halfway between those. And then it should just keep the same pattern as we go up here. So this would be what it would be. But so math can only do what math can do, right? Like it just does, like, you know. So you're the brains of the operation. Does this look okay? Because what is Y? So then anything between 5 and 40, you're going to lose money? But usually when we do well, that's what it says, right? That's what it says right now. But usually when you do these, you want the vertex to represent the maximum profit. But the vertex on this is making it look like that's how much you're going to lose that much when you do it. So something's not quite right. Because usually when we do these, it's flipped up, right? Where the maximum profit is the vertex in the positive area. And so that's what they're saying. Like, I don't know about that. That doesn't look so good. So we want to keep the same zeros because they're still zeros. Like it's still, you make no money if you charge $40 and you make no money if you charge $5. So in order for us to keep the zeros the same and flip this thing around, you just change every sign. Okay, so then instead of, where'd it go? X squared, we're going to say it's negative X squared. Yeah, so negative X squared plus 45X minus 200. And so our zeros will stay the same. And then, right, we're still 20s, boom, boom. what are we at? 10 was negative, so then it would be here. And roughly there. And so then it looks something like this then. Or as close as I can get. Okay, so you got to be careful on that because we're assuming that the vertex is the maximum. So what should they charge then?
Like
22 and a half then, yeah, right? Because that would be halfway in between 20 and 25 where the vertex is. So 22 and a half. Is that okay? All right, so the only other thing I got to say then is if you flip, because now you can do up to 57, but flip to page 291. I want to point out something that we've talked about, and then now they're seeing if you understand what they were saying. So on 49, they give us 3 zeros. And they're asking us to write a polynomial function of least degree. And here are the zeros they came up with. But we had this theorem, the complex conjugate theorem, and that's on page 285. And so back on 285, I summarized all that writing by saying what? Complex solutions always come in pairs. But they only got one up there, one imaginary. But that's impossible. That doesn't work that way. So just looking at this, you might say the degree is 3. But what you want to know, what you want to understand is that this is the other one. And so they're essentially asking you, did you pay attention and understand the complex conjugate theorem? Is that okay? And so now you're going to FOIL these.
So that'd be the same thing for 51 as well.
Yeah, right. So I'll write out what that is. I'll write out the solutions. But yeah, so 51 has one complex. So this is what you'd have to FOIL all that. So then 51, what are our zeros then? We got a -2, we got a -3, and so then we have 4 minus 3i. So what would its pair be? And think about like how the square root works with it and stuff. Because what would be the plus and minus? The 3i would get the plus and the minus. So then they didn't give us 4 plus 3i. Okay. And then you just subtract everything over, subtract/add them all over to set equal to 0. So then +2, +3, x minus 4 plus 3i, x minus 4 minus 3i. Is that okay?